Producing enough energy to meet our needs has become a serious problem. Demand is rising rapidly because of the world's increasing population and expanding industry. Burning fossil fuels like gas, coal and oil seriously damages the environment, and they'll eventually run out. For a number of years now, scientists have been working out how we can derive energy from renewable sources, such as the sun and wind, without causing pollution. Today, I'll outline marine renewable energy, also called ocean energy, which harnesses the movement of the oceans. Marine renewable energy can be divided into three main categories: wave energy, tidal energy, and ocean thermal energy conversion. And I'll say a few words about each one. First, wave energy. Numerous devices have been invented to harvest wave energy, with names such as Wave Dragon, the Penguin, and Mighty Whale. And research is going on to try and come up with a really efficient method. This form of energy has plenty of potential, as the source is constant, and there's no danger of waves coming to a standstill. Electricity can be generated using onshore systems, using a reservoir, or offshore systems. But the problem with ocean waves is that they're erratic, with the wind making them travel in every direction. This adds to the difficulty of creating efficient technology. Ideally, all the waves would travel smoothly and regularly along the same straight line. Another drawback is that sand and other sediment on the ocean floor might be stopped from flowing normally, which can lead to environmental problems. The second category of marine energy that I'll mention is tidal energy. One major advantage of using the tide rather than waves as a source of energy is that it's predictable. We know the exact times of high and low tides for years to come. For tidal energy to be effective, the difference between high and low tides needs to be at least 5 meters. And this occurs naturally in only about 40 places on Earth. But the right conditions can be created by constructing a tidal lagoon, an area of seawater separated from the sea. One current plan is to create a tidal lagoon on the coast of Wales. This will be an area of water within a bay at Swansea, sheltered by a U-shaped breakwater, or dam, built out from the coast. The breakwater will contain 16 hydro turbines, and as the tide rises, water rushes through the breakwater, activating the turbines, which turn a generator to produce electricity. Then, for 3 hours as the tide goes out, the water is held back within the breakwater, increasing the difference in water level until it's several meters higher within the lagoon than in the open sea. Then, in order to release the stored water, gates in the breakwater are opened. It pours powerfully out of the lagoon, driving the turbines in the breakwater in the opposite direction and again generating thousands of megawatts of electricity. As there are 2 high tides a day, this lagoon scheme would generate electricity 4 times a day, every day, for a total of around 14 hours in every 24, and enough electricity for over 150,000 homes. This system has quite a lot in its favour. Unlike solar and wind energy, it doesn't depend on the weather. The turbines are operated without the need for fuel, so it doesn't create any greenhouse gas emissions, and very little maintenance is needed. It's estimated that electricity generated in this way will be relatively cheap, and that manufacturing the components would create more than 2,000 jobs, a big boost to the local economy. On the other hand, there are fears that lagoons might harm both fish and birds, for example by disturbing migration patterns and causing a build-up of silt, affecting local ecosystems. There are other forms of tidal energy, but I'll go on to the third category of marine energy, ocean thermal energy conversion. This depends on there being a big difference in temperature between surface water and the water a couple of kilometres below the surface, and this occurs in tropical coastal areas. The idea is to bring cold water up to the surface using a submerged pipe. The concept dates back to 1881, when...
In this series of lectures about the history of weather forecasting, I'll start by examining its early history. That'll be the subject of today's talk. Okay, so we'll start by going back thousands of years. Most ancient cultures had weather gods, and weather catastrophes, such as floods, played an important role in many creation myths. Generally, weather was attributed to the whims of the gods, as the wide range of weather gods in various cultures shows. For instance, there's the Egyptian sun god Ra, and Thor, the Norse god of thunder and lightning. Many ancient civilizations developed rites such as dances in order to make the weather gods look kindly on them. But the weather was of daily importance. Observing the skies and drawing the correct conclusions from these observations was really important. In fact, their survival depended on it. It isn't known when people first started to observe the skies, but at around 650 BC, the Babylonians produced the first short-range weather forecasts, based on their observations of clouds and other phenomena. The Chinese also recognized weather patterns, and by 300 BC, astronomers had developed a calendar which divided the year into 24 festivals, each associated with a different weather phenomenon. The ancient Greeks were the first to develop a more scientific approach to explaining the weather. The work of the philosopher and scientist Aristotle in the 4th century BC is especially noteworthy, as his ideas held sway for nearly 2,000 years. In 340 BC, he wrote a book in which he attempted to account for the formation of rain, clouds, wind, and storms. He also described celestial phenomena such as halos, that is, bright circles of light around the sun, the moon, and bright stars, and comets. Many of his observations were surprisingly accurate. For example, he believed that heat could cause water to evaporate, but he also jumped to quite a few wrong conclusions, such as that winds are breathed out by the earth. Errors like this were rectified from the Renaissance onwards. For nearly 2,000 years, Aristotle's work was accepted as the chief authority on weather theory. Alongside this, though, in the Middle Ages, weather observations were passed on in the form of proverbs, such as red sky at night, shepherd's delight, red sky in the morning, shepherd's warning. Many of these are based on very good observations and are accurate, as contemporary meteorologists have discovered. For centuries, any attempt to forecast the weather could only be based on personal observations. But in the 15th century, scientists began to see the need for instruments. Until then, The only ones available were weather vanes to determine the wind direction and early versions of rain gauges. One of the first, invented in the 15th century, was a hygrometer, which measured humidity. This was one of many inventions that contributed to the development of weather forecasting. In 1592, the Italian scientist and inventor Galileo developed the world's first thermometer. His student Torricelli later invented the barometer, which allowed people to measure atmospheric pressure. In 1648, the French philosopher Pascal proved that pressure decreases with altitude. This discovery was verified by English astronomer Halley in 1686, and Halley was also the first person to map trade winds. This increasing ability to measure factors related to weather helped scientists to understand the atmosphere and its processes better, and they started collecting weather observation data systematically. In the 18th century, the scientist and politician Benjamin Franklin carried out work on electricity and lightning in particular, but he was also very interested in weather and studied it throughout most of his life. It was Franklin who discovered that storms generally travel from west to east. In addition to new meteorological instruments, other developments contributed to our understanding of the atmosphere. People in different locations began to keep records, and in the mid-19th century, the invention of the telegraph made it possible for these records to be collated. This led, by the end of the 19th century, to the first weather services. It was not until the early 20th century that mathematics and physics became part of meteorology, and we'll continue from that point next week.
That is the end of section 4. You now have half a minute to check your answers. That is the end of the listening test. In the IELTS test, you would now have 10 minutes to transfer your answers to the answer sheet. IELTS 14, Tests 1 to 4. Published by Cambridge University Press and Uckells 2019. This recording is copyright. Test 3. You will hear a number of different recordings, and you will have to answer questions on what you hear. There will be time for you to read the instructions and questions, and you will have a chance to check your work. All the recordings will be played once only. The test is in 4 sections. At the end of the test, you will be given 10 minutes to transfer your answers to an answer sheet. Now turn to section 1. Section 1. You will hear a man phoning the customer services manager of a hotel to get information about holding a conference there. First, you have some time to look at questions 1 to 5. You will see that there is an example that has been done for you. On this occasion only, the conversation relating to this will be played first.
Hello, Flanders Conference Hotel.
Oh, hi. I wanted to ask about conference facilities at the hotel. Have I come through to the right person?
You have. I'm the Customer Services Manager. My name's Angela.
The name of the Customer Services Manager is Angela. So Angela has been written in the space. Now we shall begin. You should answer the questions as you listen, because you will not hear the recording a second time. Listen carefully and answer questions 1 to 5.
Hello, Flanders Conference Hotel.
Oh, hi. I wanted to ask about conference facilities at the hotel. Have I come through to the right person?
You have. I'm the Customer Services Manager. My name's Angela. So, how can I help you?
Well, I'm calling from Barrett and Stansons. We're a medical company based in Perth.
Oh, yes?
And we're organising a conference for our clients to be held in Sydney. It'll be held over 2 days, and we're expecting about 50 or 60 people.
When were you thinking of having it?
Sometime early next year, like the end of January. It'd have to be a weekend.
Let me see. Our conference facilities are already booked for the weekend beginning January the 28th. We could do the first weekend in February.
How about January the 21st?
I'm afraid that's booked too.
Well, let's go for the February date then.
So, that's the weekend beginning the 4th.
Okay. Now, can you tell me a bit about what conference facilities you have?
Sure. So, for talks and presentations, we have the Tesla room.
Sorry?
Tesla, that's spelled T-E-S-L-A. It holds up to 100 people, and it's fully equipped with a projector and so on.
How about a microphone?
Yes, that'll be all set up ready for you. And there'll be one that members of the audience can use too, for questions if necessary.
Fine. And we'll also need some sort of open area where people can sit and have a cup of coffee. And we'd like to have an exhibition of our products and services there as well, so that'll need to be quite a big space.
That's fine. There's a central atrium with all those facilities, and you can come before the conference starts if you want to set everything up.
Great. And I presume there's Wi-Fi?
Oh, yes. That's free and available throughout the hotel.
Okay.
Would you also like us to provide a buffet lunch? We can do a 2-course meal with a number of different options.
What sort of price are we looking at for that?
Well, I can send you a copy of the standard menu. That's $45 per person. Or you can have the special for $25 more.
I think the standard should be okay, but yes, send me the menu.
Before you hear the rest of the conversation, you have some time to look at questions 6 to 10. Now listen and answer questions 6 to 10.
Now, we're also going to need accommodation on the Saturday night for some of the participants. I'm not sure how many, but probably about 25. So what do you charge for a room?
Well, for conference attendees, we have a 25% reduction, so we can offer you rooms at $135. Normally, a standard room's $180.
And does that include breakfast?
Sure. And of course, guests can also make use of all the other facilities at the hotel. So we've got a spa where you can get massages and facials and so on. And there's a pool up on the roof for the use of guests.
Oh, great. Now, what about transport links? The hotel's downtown, isn't it?
Yes, it's about 12 kilometres from the airport, but there's a complimentary shuttle bus for guests, and it's only about 10 minutes walk from the Central Railway Station.
Okay. Now, I don't know Sydney very well. Can you just give me an idea of the location of the hotel?
Well, it's downtown on Wilby Street. That's quite a small street, and it's not very far from the sea. And of course, if the conference attendees want to go out on the Saturday evening, there's a huge choice of places to eat. Then, if they want to make a night of it, they can go on to one of the clubs in the area. There are a great many to choose from.
Okay. So, if we go ahead with this, can you give me some information about how much we're looking at?
That is the end of section 1.
As you all know, the university is planning an arts festival for later this year, and here in the music department, we've planned 3 concerts. These will be public performances, and the programme has just been finalised. The theme of the festival is links between the UK and Australia, and this is reflected in the music. Each concert will feature both British and Australian composers. I'll tell you briefly about the Australian music, as you probably won't be familiar with that. The first concert will include music by Liza Lim, who was born in Perth, Western Australia, in 1966. As a child, Lim originally learned to play the piano, like so many children, and also the violin. But when she was 11, her teachers encouraged her to start composing. She found this was her real strength, and she studied and later taught composition, both in Australia and in other countries. As a composer, she has received commissions from numerous orchestras, other performers, and festivals in several countries. Liza Lim's compositions are vibrant and full of energy, and she often explores Asian and Australian Aboriginal cultural sources, including the native instrument, the didgeridoo. This is featured in a work called The Compass. Her music is very expressive, so although it is complex, it has the power of connecting with audiences and performers alike. In the festival, we're going to give a semi-staged performance of the Oresteia. This is an opera in 7 parts, based on the trilogy of ancient Greek tragedies by Aeschylus. Lim composed this when she was in her mid-20s, and she also wrote the text, along with Barry Kosky. It's performed by 6 singers, a dancer, and an orchestra that, as well as standard orchestral instruments, includes electric guitar and a traditional Turkish stringed instrument. Lim wrote that because the stories in the tragedies are not easy to tell. The sounds she creates are also disturbing, and they include breathing, sobbing, laughing, and whistling. The work lasts around 75 minutes, and the rest of the concert will consist of orchestral works by the British composers Ralph Vaughan Williams and Frederick Delius. Moving on now to our second concert. This will begin with instrumental music by British composers Benjamin Britten and Judith Weir. After the interval, we'll go to Australia for a piece by Ross Edwards, The Tower of Remoteness. According to Edwards, the inspiration for this piece came from nature, when he was sitting alone in the dry bed of a creek, overshadowed by the leaves of palm trees, listening to the birds and insects. The Tower of Remoteness is scored for piano and clarinet. Edwards says he realized years after writing the piece that he had subconsciously modelled its opening phrase on a bird call. Ross Edwards was born in 1943 in Sydney, Australia, and studied at the Sydney Conservatorium of Music and the Universities of Adelaide and Sydney. He's well known in Australia, and in fact, he's one of the country's most performed composers. He's written a wide range of music, from symphonies and concertos to some composed specifically for children. Edwards's music has been described as being deeply connected to Australia, and it can be regarded as a celebration of the diversity of cultures that Australia can be proud of. The last of the three Australian composers to be represented in our festival is Carl Vine. Born in 1954, Vine, like Liza Lim, comes from Perth, Western Australia. He took up the cornet at the age of 5, switching to the piano 5 years later. However, he went to university to study physics before changing to composition. After graduating, he moved to Sydney and worked as a freelance pianist and composer. Before long, he had become prominent in Australia as a composer for dance, and in fact has written 25 scores of that type. In our third concert, Vine will be represented by his music for the flag handover ceremony of the Olympics held in 1996. This 7-minute orchestral piece was of course heard by millions of people worldwide, and we'll hear it alongside works written by British composers Edward Elgar and, more recently, Thomas Adès.
In today's class, I'm going to talk about marine archaeology, the branch of archaeology focusing on human interaction with the sea, lakes and rivers. It's the study of ships, cargoes, shipping facilities and other physical remains. I'll give you an example, then go on to show how this type of research is being transformed by the use of the latest technology. Atlit Yam was a village on the coast of the eastern Mediterranean, which seems to have been thriving until around 7000 BC. The residents kept cattle, caught fish, and stored grain. They had wells for fresh water. Many of their houses were built around a courtyard and were constructed of stone. The village contained an impressive monument, 7 half-ton stones standing in a semicircle around a spring that might have been used for ceremonial purposes. Atlit Yam may have been destroyed swiftly by a tsunami, or climate change may have caused glaciers to melt and sea levels to rise, flooding the village gradually. Whatever the cause, it now lies 10 metres below the surface of the Mediterranean, buried under sand at the bottom of the sea. It's been described as the largest and best preserved prehistoric settlement ever found on the seabed. For marine archaeologists, Atlit Yam is a treasure trove. Research on the buildings, tools, and the human remains has revealed how the bustling village once functioned, and even what diseases some of its residents suffered from. But of course, this is only one small village, one window into a lost world. For a fuller picture, researchers need more sunken settlements, but the hard part is finding them. Underwater research used to require divers to find shipwrecks or artifacts, but in the second half of the 20th century, various types of underwater vehicles were developed, some controlled from a ship on the surface, and some of them autonomous. which means they don't need to be operated by a person. Autonomous underwater vehicles, or AUVs, are used in the oil industry, for instance, to create maps of the seabed before rigs and pipelines are installed. To navigate, they use sensors, such as compasses and sonar. Until relatively recently, they were very expensive and so heavy that they had to be launched from a large vessel with a winch. But the latest AUVs are much easier to maneuver. They can be launched from the shore or a small ship, and they're much cheaper, which makes them more accessible to research teams. They are also very sophisticated. They can communicate with each other and, for example, work out the most efficient way to survey a site or to find particular objects on the seabed. Field tests show the approach can work. For example, in a trial in 2015, 3 AUVs searched for wrecks at Marzi off the coast of Sicily. The site is the final resting place of an ancient Roman ship, which sank in the 6th century AD, while ferrying prefabricated marble elements for the construction of an early church. The AUVs mapped the area in detail, finding other ships carrying columns of the same material. Creating an internet in the sea for AUVs to communicate is no easy matter. Wi-Fi networks on land use electromagnetic waves, but in water, these will only travel a few centimetres. Instead, a more complex mix of technologies is required. For short distances, AUVs can share data using light, while acoustic waves are used to communicate over long distances. But more creative solutions are also being developed, where an AUV working on the seabed offloads data to a second AUV, which then surfaces and beams the data home to the research team using a satellite. There's also a system that enables AUVs to share information from seabed scans and other data. So, if an AUV surveying the seabed finds an intriguing object, it can share the coordinates of the object, that is, its position, with a nearby AUV that carries superior cameras, and arrange for that AUV to make a closer inspection of the object. Marine archaeologists are excited about the huge potential of these AUVs for their discipline. One site where they're going to be deployed is the Gulf of Baratti off the Italian coast. In 1974, a 2,000-year-old Roman vessel was discovered here in 18 metres of water. When it sank, it was carrying medical goods in wooden or tin receptacles. Its cargo gives us insight into the treatments available all those years ago, including tablets that are thought to have been dissolved to form a cleansing liquid for the eyes. Other Roman ships went down nearby, taking their cargoes with them. Some held huge pots made of terracotta. Some were used for transporting cargoes of olive oil, and others held wine. In many cases, it's only these containers that remain, while the wooden ships have been buried under silt on the seabed. Another project that's about to be...
Hi. Today we're going to be looking at animals in urban environments, and I'm going to be telling you about some research on how they're affected by these environments. Now, in evolutionary terms, urban environments represent huge upheavals, the sorts of massive changes that usually happen over millions of years. And we used to think that only a few species could adapt to this new environment. One species which is well known as being highly adaptable is the crow, and there have been various studies about how they manage to learn new skills. Another successful species is the pigeon, because they're able to perch on ledges on the walls of city buildings, just like they once perched on cliffs by the sea. But, in fact, we're now finding that these early immigrants were just the start of a more general movement of animals into cities, and of adaptation by these animals to city life. And one thing that researchers are finding especially interesting is the speed with which they're doing this. We're not talking about gradual evolution here. These animals are changing fast. Let me tell you about some of the studies that have been carried out in this area. So, in the University of Minnesota, a biologist called Emily Snellrud and her colleagues looked at specimens of urbanized small mammals such as mice and gophers that had been collected in Minnesota and that are now kept in museums there. And she looked at specimens that had been collected over the last 100 years, which is a very short time in evolutionary terms. And she found that during that time, these small mammals had experienced a jump in brain size when compared to rural mammals. Now, we can't be sure this means they're more intelligent, but since the sizes of other parts of the body didn't change, it does suggest that something cognitive was going on. And Snellrud thinks that this change might reflect the cognitive demands of adjusting to city life, having to look in different places to find food, for example, and coping with a whole new set of dangers. Then over in Germany, at the Max Planck Institute, there's another biologist called Katharina Miranda, who's done some experiments with blackbirds living in urban and rural areas, and she's been looking not at their anatomy, but at their behavior. So, as you might expect, she's found that the urban blackbirds tend to be quite bold. They're prepared to face up to a lot of threats that would frighten away their country counterparts. But there's one type of situation that does seem to frighten the urban blackbirds, and that's anything new, anything they haven't experienced before. And if you think about it, that's quite sensible for a bird living in the city. Jonathan Atwell, in Indiana University, is looking at how a range of animals respond to urban environments. He's found that when they're under stress, their endocrine systems react by reducing the amount of hormones such as corticosterone into their blood. It's a sensible-seeming adaptation. A rat that gets scared every time a subway train rolls past won't be very successful. There's just one more study I'd like to mention, which is by Sarah Parton and her team. And they've been looking at how squirrels communicate in an urban environment, and they've found that a routine part of their communication is carried out by waving their tails. You do also see this in the country, but it's much more prevalent in cities, possibly because it's effective in a noisy environment. So, what are the long-term implications of this? One possibility is that we may see completely new species developing in cities. But on the other hand, it's possible that not all of these adaptations will be permanent. Once the animals got accustomed to its new environment, it may no longer need the features it's developed. So now we've had a look at adaptation.
Today, we'll be continuing the series of lectures on memory by focusing on what is called episodic memory and what can happen if this is not working properly. Episodic memory refers to the memory of an event or episode. Episodic memories allow us to mentally travel back in time to an event from the past. Episodic memories include various details about these events. For example, when an event happened and other information such as the location, To help understand this concept, try to remember the last time you ate dinner at a restaurant. The ability to remember where you ate, who you were with, and the items you ordered are all features of an episodic memory. Episodic memory is distinct from another type of memory called semantic memory. This is the type of factual memory that we have in common with everyone else. That is your general knowledge of the world. To build upon a previous example, remembering where you parked your car is an example of episodic memory. But your understanding of what a car is and how an engine works are examples of semantic memory. Unlike episodic memory, semantic memory isn't dependent on recalling personal experiences. Episodic memory can be thought of as a process with several different steps of memory processing, encoding, consolidation, and retrieval. The initial step is called encoding. This involves the process of receiving and registering information which is necessary for creating memories of information or events that you experience. The degree to which you can successfully encode information depends on the level of attention you give to an event while it's actually happening. Being distracted can make effective encoding very difficult. Encoding of episodic memories is also influenced by how you process the event. For example, if you were introduced to someone called Charlie, you might make the connection that your uncle has the same name. Future recollection of Charlie's name is much easier if you have a strategy to help you encode it. Memory consolidation, the next step in forming an episodic memory, is the process by which memories of encoded information are strengthened, stabilized, and stored to facilitate later retrieval. Consolidation is most effective when the information being stored can be linked to an existing network of information. Consolidation makes it possible for you to store memories for later retrieval indefinitely. Forming strong memories depends on the frequency with which you try to retrieve them. Memories can fade or become harder to retrieve if they aren't used very often. The last step in forming episodic memories is called retrieval, which is the conscious recollection of encoded information. Retrieving information from episodic memory depends upon semantic, olfactory, auditory, and visual factors. These help episodic memory retrieval by acting as a prompt. For example, when recalling where you parked your car, you may use the colour of a sign close to where you parked. You actually have to mentally travel back to the moment you parked. There are a wide range of neurological diseases and conditions that can affect episodic memory. These range from Alzheimer's to schizophrenia to autism. An impairment of episodic memory can have a profound effect on individuals' lives. For example, the symptoms of schizophrenia can be reasonably well controlled by medication. However, patients' episodic memory may still be impaired, and so they are often unable to return to university or work. Recent studies have shown that computer-assisted games designed to keep the brain active can help improve their episodic memory. Episodic memories can help people connect with others, for instance by sharing intimate details about their past, something individuals with autism often have problems with. This may be caused by an absence of a sense of self. This is essential for the storage of episodic memory and has been found to be impaired in children with autism. Research has shown that treatments that improve memory may also have a positive impact on children's social development. One study looked at
Last week we started looking at reptiles, including crocodiles and snakes. Today, I'd like us to have a look at another reptile, the lizard, and in particular, at some studies that have been done on a particular type of lizard whose Latin name is Tiliqua rugosa. This is commonly known as the sleepy lizard because it's quite slow in its movements and spends quite a lot of its time dozing under rocks or lying in the sun. I'll start with a general description. Sleepy lizards live in Western and South Australia, where they're quite common. Unlike European lizards, which are mostly small, green and fast-moving, sleepy lizards are brown, but what's particularly distinctive about them is the colour of their tongue, which is dark blue, in contrast with the lining of their mouth, which is bright pink. And they're much bigger than most European lizards. They have quite a varied diet, including insects and even small animals, but they mostly eat plants of varying kinds. Even though they're quite large and powerful, with strong jaws that can crush beetles and snail shells, they still have quite a few predators. Large birds like cassowaries were one of the main ones in the past, but nowadays they're more likely to be caught and killed by snakes. Actually, another threat to their survival isn't a predator at all, but is man-made. Quite a large number of sleepy lizards are killed by cars when they're trying to cross highways. One study carried out by Michael Freak at Flinders University investigated the methods of navigation of these lizards. Though they move slowly, they can travel quite long distances. And he found that even if they were taken some distance away from their home territory, they could usually find their way back home as long as they could see the sky. They didn't need any other landmarks on the ground. Observations of these lizards in the wild have also revealed that their mating habits are quite unusual. Unlike most animals, it seems that they're relatively monogamous, returning to the same partner year after year. And the male and female also stay together for a long time, both before and after the birth of their young. It's quite interesting to think about the possible reasons for this. It could be that it's to do with protecting their young. You'd expect them to have a much better chance of survival if they have both parents around. But in fact, observers have noted that once the babies have hatched out of their eggs, they have hardly any contact with their parents. So there's not really any evidence to support that idea. Another suggestion's based on the observation that male lizards in monogamous relationships tend to be bigger and stronger than other males. So maybe the male lizards stay around so they can give the female lizards protection from other males. But again, we're not really sure. Finally, I'd like to mention another study that involved collecting data by tracking the lizards. I was actually involved in this myself. So we caught some lizards in the wild and we developed a tiny GPS system that would allow us to track them and we fixed this onto their tails. Then we set the lizards free again, and we were able to track them for 12 days and gather data, not just about their location, but even about how many steps they took during this period. One surprising thing we discovered from this is that there were far fewer meetings between lizards than we expected. It seems that they were actually trying to avoid one another. So why would that be? Well, again, we have no clear evidence, but one hypothesis is that male lizards can cause quite serious injuries to one another. So maybe this avoidance is a way of preventing this, of self-preservation, if you like. But we need to collect a lot more data before we can be sure of any of this.
That is the end.
In my presentation, I'm going to talk about coffee and its importance both in economic and social terms. We think it was first drunk in the Arab world, but there's hardly any documentary evidence of it before the 1500s, although of course that doesn't mean that people didn't know about it before then. However, there is evidence that coffee was originally gathered from bushes growing wild in Ethiopia, in the northeast of Africa. In the early 16th century, it was being bought by traders, and gradually its use as a drink spread throughout the Middle East. It's also known that in 1522, in the Turkish city of Constantinople, which was the centre of the Ottoman Empire, the court physician approved its use as a medicine. By the mid-1500s, coffee bushes were being cultivated in the Yemen, and for the next 100 years, this region produced most of the coffee drunk in Africa and the Arab world. What's particularly interesting about coffee is its effect on social life. It was rarely drunk at home, but instead people went to coffee houses to drink it. These people, usually men, would meet to drink coffee and chat about issues of the day. But at the time, this chance to share ideas and opinions was seen as something that was potentially dangerous. And in 1623, the ruler of Constantinople demanded the destruction of all the coffee houses in the city, although after his death, many new ones opened and coffee consumption continued. In the 17th century, coffee drinking spread to Europe, and here too, coffee shops became places where ordinary people, nearly always men, could meet to exchange ideas. Because of this, some people said that these places performed a similar function to universities. The opportunity they provided for people to meet together outside their own homes and to discuss the topics of the day had an enormous impact on social life, and many social movements and political developments had their origins in coffeehouse discussions. In the late 1600s, the Yemeni monopoly on coffee production broke down, and coffee production started to spread around the world, helped by European colonization. Europeans set up coffee plantations in Indonesia and the Caribbean, and production of coffee in the colonies skyrocketed. Different types of coffee were produced in different areas, and it's interesting that the names given to these different types, like Mocha or Java coffee, were often taken from the port they were shipped to Europe from. But if you look at the labour system in the different colonies, there were some significant differences. In Brazil and the various Caribbean colonies, coffee was grown in huge plantations, and the workers there were almost all slaves. But this wasn't the same in all colonies. For example, in Java, which had been colonised by the Dutch, the peasants grew coffee and passed a proportion of this on to the Dutch, so it was used as a means of taxation. But whatever system was used, under the European powers of the 18th century, coffee production was very closely linked to colonisation. Coffee was grown in ever-increasing quantities to satisfy the growing demand from Europe,
and it became nearly as important as sugar production, which was grown under very similar conditions. However, coffee prices were not yet low enough for people to drink it regularly at home, so most coffee consumption still took place in public coffee houses, and it still remained something of a luxury item. In Britain, however, a new drink was introduced from China and started to become popular, gradually taking over from coffee, although at first it was so expensive that only the upper classes could afford it. This was tea, and by the late 1700s it was being widely drunk. However, when the USA gained independence from Britain in 1776, they identified this drink with Britain, and coffee remained the preferred drink in the USA, as it still is today. So, by the early 19th century, coffee was already being widely produced and consumed. But during this century, production boomed, and coffee prices started to fall. This was partly because new types of transportation had been developed, which were cheaper and more efficient. So now, working people could afford to buy coffee. It wasn't just a drink for the middle classes. And this was at a time when large parts of Europe were starting to work in industries. And sometimes this meant their work didn't stop when it got dark. They might have to continue throughout the night. So the use of coffee as a stimulant became important. It wasn't just a drink people drank in the morning for breakfast. There were also changes in cultivation.